Good day everyone, we are Group Cybergenesis, and today we will present Arduino Project 9 Light Sensitive LED. Our group members are Nanjoy Nashtiglao, our leader, myself, Marcia Marpuntillo, and John Michael Pajeda. We work together to complete this project. This project is presented to our professor, Dr. Earl Marquez Albina, for our subject Application Development and Emerging Technologies. In this lesson, we were introduced to a new sensor called the photodiode. This sensor changes its resistance depending on the light it detects. The brighter the light, the lower its resistance. In darkness, its resistance becomes higher. By reading this change, we can measure the light level around us. We use this concept to create an automatic light system. When it becomes dark, the photodiode triggers the LED to turn on, and when it is bright, the LED turns off automatically. The components we used for this project are: first, Arduino Uno board, the main controller; second, breadboard for building and connecting the circuit; third, jumper wires to connect the components; fourth, photodiode detects the level of ambient light; fifth, resistor regulates the current to protect the components; and lastly, LED acts as the automatic light that turns on or off. So with these components, we created a working light-sensitive LED system that reacts to its surroundings.
Today, we'll be explaining our Arduino project, an automatic light system that turns an LED on or off depending on the light level detected by a photoresistor. Alright, let's start with the first line. In kpin LED equals 13. This creates a variable called kpin LED and assigns it the value 13. This means our LED is connected to digital pin 13. Next, we have int val equals 0. This creates a variable called val, and it sets to 0. This will store the voltage value read from the photoresistor. Now we move to the setup function, void setup. This part runs only once when the Arduino starts. Inside setup, we have pin mode kpin LED output. This sets the LED pin as an output so the Arduino can turn the LED on or off. Next is the serial.begin with a value of 9600. This starts the serial communication at 9600 bits per second, so we can send the light sensor readings to the serial monitor. And then we close the setup with closing curly bracket. Next is the loop function, void loop. This is the part of the code that runs continuously. Inside the loop, we have val equals analog read the value of 2. This reads the voltage from analog pin A2 where our photoresistor is connected. And it stores it in the variable val. Then we have serial.println val. This prints the value of val to the serial monitor so we can see the light level in real time. Next is an if statement. If val is less than 300. This checks if the light level is below 900. If it is, that means the environment is bright enough so the LED will be turned off. Inside this condition, we have digital write K-pin LED low. This turns the LED off. If the light level is not below 900, the else statement runs digital write K-pin LED high, which turns the LED on, meaning it's dark enough for the light to activate. Finally, we have delay with the value of 10. This pauses the program for 10 milliseconds before taking the next reading, which helps stabilize the output. So in summary, this project uses a photoresistor to detect light levels. If it's bright, the LED stays off. If it's dark, the LED turns on automatically. That's how our Arduino Autolight project works.
Alright, here, so as you can see, the light is not lighting up. The LED is not lighting up because the value that is being inputted in our serial monitor is less than 900. So that means we're not getting any output. We're not sending any electrical signals to this LED light. So what if we cover up the sensor so that it doesn't detect any light? Oh, it is lighting up. Look at that. Look, it's lighting up. Because it's not receiving any light, it's now detecting that the analog value is more than 900. It's actually at the maximum, which is 1023. It's awesome.